Hello, solar station owners, solar station installers, and all the entrepreneurs who are already thinking about their own solar station. My name is Alexander Smazhuk, and today I represent the Unisolar company, which has been comprehensively installing solar power plants for more than 15 years in Ukraine and already in Moldova and Lithuania. Today we will talk to Mr. Rafal. He is a representative of one of our partners and at the same time one of the world's leading solar panel manufacturers, LONGi. This conversation we will focus on production technology, which unlike many manufacturers is being actively developed by LONGi. I mean the Hybrid Passivated Back Contact. Preparing to this meeting, I found a range of myths and legends about this unique HPDC technology from LONGi. So right now, first of all, I want to give possibility to my guest to tell a little bit more about himself and how did he come into this energy solar niche and to the LONGi company. And after that, I will give him my questions to disprove or to confirm the myths I've found.
So hello everybody, I'm Rafal Nestepski. I'm the product marketing manager in LONGi, responsible for the whole Eastern European region. So how I get to this niche, how I get to the PV industry. So to be honest, starting from my studies, I already entered the scope in which we were very much linked to the renewable energy. My master and my bachelor thesis are very much linked to the energy storage systems and as well the PV industry and PV production, so the electricity production from the solar. I started with the installer company, then I smoothly came to the production and manufacturers. I used to work at one of the biggest inverters manufacturer, and now I'm in LONGi. Is the company who produce the PV solar systems, PV modules, to be honest. And this is my road to this place.
Why LONGi? Why did you choose this company? What is so interesting in your company?
So LONGi is one of the biggest PV modules manufacturers in the world. They have quite a big history of their company because the company was established in 2000. And at first they were very much focused only on the production of the silicon ingots and wafers. So this is the very first step of the production of the whole PV module. Then in 2014, they started the production of the PV modules. So as you can see, the first phase was the production of the ingots and wafers from the pure silicon, and then they started to produce also the PV modules as well. And also one good thing about this company is that it's constantly developing. So in 2021, LONGi established a new branch. It's called LONGi Hydrogen, where we are doing electrolyzers. What is electrolyzers? Electrolyzers are the machines that produce the pure hydrogen out of the energy harvested from the PV modules.
Pretty interesting technology. As we start to talk about some technologies, I know that your company is working with technology of back contact. Maybe you can explain to our listeners, to all our dealers who are working with Unisolar company, what is this technology, in fact, but in some like small talk, some easiest way to understand, because not all of us are technicians and not all of us could understand this high materials, but we want to understand, is this technology capable right now, and is it does it have future?
So maybe we should start like this. At first, I will describe a little bit about our R&D sector, because it came from our R&D part. So in our R&D, we have more than 4,000 people who are constantly working on the improvement of the wafers of the PV modules as well. And there was the idea was born, to be honest, to establish a back contact technology. So at first it started in 2018, where we already developed a couple of world records in the P-type TOPCon, N-type TOPCon, and HFT technology as well. So combining those three paths, let's say, it's not like this that we only focus on the back contact technology. We researched TOPCon, we researched HFT, and during our research for the HFT and TOPCon, we started and established a good mass line production for the back contact technology. And having enhanced three top technologies out of the market, so the TOPCon, HFT, and back contact, LONGi decided to go with the back contact due to the thing that the back contact technology has the most theoretical maximum efficiency out of these three available technologies.
But as I understand, there is some myth that this technology is pretty expensive, is more expensive than other technologies. Is it so?
Of course, the production of this technology is quite difficult. The transition from the PERC to TOPCon is much less capital consumption than transiting from the PERC to the back contact. But as LONGi was thinking of which road to pick, there was a big growth of the TOPCon manufacturers out in China. And from our perspective, due to this boom for the TOPCon, it will be very short time for the TOPCon to have a payback period of its investments. And back contact will enter the market due to the thing that back contact is a platform. It opens variety of possibilities because with the back contact, we can as well combine it with the TOPCon technology, with the HFT technology, and it also have a potential to combine future cells technologies.
So you mean that this back contact technology is not some new road? It's the technology which could be combined with another technologies to make the results better. Just in this case, yeah.
Yeah. So basically, on the other hand, if TOPCon HLT wants to improve their efficiency, they need to combine themselves with the back contact technology. It's the only known road by now. This is the fact that TOPCon and HLT are almost at the highest level of their efficiencies in the market. And back contact have a future potential for the future growth. Of course, this technology, due to the more capital consumption for the production, is a little bit more costly, but the payback period when using back contact can be shorter even when comparing it to the TOPCon models.
So maybe we'll tell me about some models of your new technology, which already are using on the stations, on the solar stations.
So in our back contact road, we have 4 main branches of the products. We have an Explorer series, which is like a standard products with the back contact technology. We have a Scientist family. This family is very much focused on the raw power, the PV modules, and efficiency. So this Scientist family is a family which has the biggest and highest efficiency out of the market. We have also Guardian series. So the Guardian series is a back contact technology combined with some special features. And in this family, we have 2 types of the PV module. One is anti-dust. So anti-dust design allows rain or snow to smoothly pour out of the module. And the anti-humidity and heat, where we are using special encapsulation in the PV module that decreases the annual degradation of the PV module. So the annual degradation is only 0.35%. And fourth family is an artist family, in which we have the Ultra Black series. It's a series that is focused only on the aesthetic of the installation. It has a pure black appearance, like a black hole.
Some of people on the market, I heard this idea that does this technology, in fact, does not have future.
Maybe they are talking about it due to the fact that the price from the previous companies that wanted to introduce this company was very, very, very high compared to the PERC or TOPCon models. LONGi is known for their ability to fit new technologies into the mass production with a reasonable price for it. Of course, a couple of companies has already tried to use the back contact technology in their products. Some of them failed in this process, but looking at the history of the LONGi was one of the first companies to focus only on the monocrystalline PV models. And what is the outcome now on the market? 95% or even 99% of the PV models out of the market are monocrystalline. And as I said, LONGi from the very beginning was focused only on production of the monocrystalline PV models. Then also LONGi was one of the first companies who introduced the half cuts. Now we can see on the market that this is almost the only way to produce the PV model. And we accept that this will also be with the back contact technology. We are one of the first to introduce it to the market, but going to the future, we think that the back contact will be the majority of the PV models. Some of the research are already known widely that in 2025, it is expected that 15 to 20% of the whole global share of the PV models will be the back contact ones.
I hope that these arguments would explain to our listeners that this technology already have the future and it is started right now. Okay, I heard that HPDC, this technology is, let's say, less reliable than regular PERC technology.
It's quite funny myth, to be honest. Let's do step by step. At first, PERC technology was very popular and probably it's still quite popular in some markets. So first thing worth to mention is the cell thickness. So in PERC technologies, the cell thickness is about 180 micrometers. Looking at the market now, where everybody is promoting TOPCons, in the N-type TOPCons, the wafer thickness is only 120 micrometers. So it's a drop for 60 micrometers. And I don't hear much of the rumor on the market that N-type TOPCons are less reliable than PERC. And going to our product, back contact technology, so the Hybrid Passivated Back Contact, HPBC, our wafers are thicker than N-type TOPCons. They have about 155 micrometers. So they are thicker even than N-type TOPCons that are very popular on the market. Of course, they are a little bit thinner than PERC ones, but we need to combine it to the second advantage of our PV modules, which is the welding. The welding are these grid lines that are coming on the cells on the top and on the bottom in the PERC or TOPCon. In the back contact technology, all of the bus bars, all of the grid lines are under the cell. So imagine this. In the standard PERC or TOPCon, we need to go with the bus bar from the top of the cell to the bottom of the next cell to make it in the series connection. Doing this Z shape, because it's called Z shape, we are putting pressure, the stress on the edges of the cell. Imagine this. On the market, some manufacturers are using the same welding structure, the Z shape, from the PERC to the TOPCon models, which are using much thinner wafers, much thinner cells. In back contact technology, we are also using a little bit thinner wafers, but we are getting rid of this stress on the edges of the cell due to the thing that all of the grid lines are going under the cell. So we are not applying pressure on the edges of the cell. We are releasing almost 50% of this stress that was generated by this Z-shaped welding. So combining those two factors, one, cell thickness, and this back contact technology, we can even say that our PV modules are much more reliable and much more resistant to any mechanical damage and mechanical load than TOPCon models.
Okay, I think that this myth is ruined at all. The next one thing that I heard from the audience is that this HPDC technology is not very environmentally friendly.
Okay, going through this myth, we have all of the certificates that allows us for entering the market, and even maybe in Eastern Europe it's not so popular to achieve some special carbon footprint certificates or environmental certificates, but nevertheless in the France we need to have additional certificates for the carbon footprint and impact on the environmental for these products. And we are offering those products in the France market. So we have a special certificates aside of the ones that are, of course, demanded to sell on the whole European European region. Going further, talking about the environmental friendly. In 2021, LONGi introduced a special program, which is called LONGi Life Cycle Quality of Our Products. In this program, aside of the standard tests, they are called ISO-E tests for our factories, we established some more restricted requirements, as well for the quality of the products, but also for the impact on the environment. Outcome of it is that one of our factories in which we are producing the HYMO X6 back contact technology is utilizing 99% of the electricity from the renewable solutions. Mm-hmm. So in 2028, we are forecasting that all of our factories will be operating on the renewable solution electricity only. So there won't be any question how much coal was needed to produce this PV module. We will say zero, because all of the energy was produced by the renewable solutions.
That's perfect information. I hope that all our listeners, all our dealers and customers would appreciate this way of production and will use your panels for their stations. A few last things. As we are talking today about different myths of near of your technologies, I heard some information that such PV models with HPDC technology could have a little bit lower degradation resistance.
Answering this question, it is real that in our HPBC technology we are still using P-type wafers. Mm-hmm. P-type wafers are known for their little bit higher degradation than N-type wafers. For example, N-type wafers have this first year degradation of 1%, and in our case it's 1.5%. But still, back contact technology demands from us as a company to produce much higher pure wafers and cells from the silicon. Mm-hmm. It is just one of the ingredients to be successful in the back contact technology, to use the purer cells. Other thing is that if we are speaking about the overall efficiency of the PV module, if we will combine this drop from the first year, but with the efficiency of the PV module, which is higher than N-type TOPCon, we will still end up at the higher efficiency and higher power than most of the N-type TOPCons. Why we are achieving such a good results with the P-type technology? One of the factors was that I already said that P-type and that we need to use the higher purity P-type wafers. Second thing is that those cells that we are using doesn't have these grid lines on the front. This allows the whole sun rays to enter the cell itself. So we have a higher chance to produce the electricity because more rays can enter the cell. In standard PERC or TOPCon technology, we have bus bars in the front of the cell. These bus bars are causing shadow and also reflection of some of the rays, in which back contact doesn't have these grid lines. Another thing is that in most TOPCon modules, especially the monofacial one, manufacturers are using EVA foil. EVA foil is not so much humidity resistance than POE. And N-type wafers are much more fragile to degradation caused by humidity. One of the tests, which is called damp heat test, maybe I will describe a little bit damp heat test. What is it? So here are putting the PV module in the chamber for 1000 hours, 85 Celsius degrees, 85% of the humidity for 1000 hours. This is a standard test, and the modules need to show that their degradation after this test is less than 5% to achieve the certificate. After this test, most of the TOPCons degrade by 4.5%. In our case, in HPBC technology, our degradation is 0.38%. What can we combine this test to? So as I was speaking with some of the guys in R&D, they told me that this test represents 7 to 8 years operation on the roof for these PV modules. And please keep in mind that this degradation curve, this is the maximum degradation that is warranted by the manufacturer. As we are seeing through our installations, our modules degrade much less than stated in this curve.
What is the regular numbers?
To be honest, it's vary a little bit in the localization, but it's significantly lower than the one stated in the in this warranty performance.
So in fact, truly say there are no some big difference between PERC technology and your technology.
In fact, we are even combining some of the features from the PERC technology in our HPBC technology. As well, we are combining some features from the TOPCon technology in our HPBC technology. Why is that? Because as I said earlier, back contact technology is a platform on which we can combine different technologies. We can put best features from the PERC, best features from the TOPCon, or even best features from the HLT and mix them up on this back contact grid lines. And HPBC technology, in the simple words, we can say that this is the technology that combines tunneling oxide passivation from the TOPCon with the self-developed cell of the LONGi, and it results with the hybrid passivated back contact. We are also adding the multi-layer passivation on the front side of the cell. Why we are doing it? We need to keep in mind that all of the electrodes are on the bottom side of the cell. So if any electricity is produced on the top side of the cell, we need to push those electrons to the bottom side. That's why we also need this multi-passivation layer on the front side.
Pretty much technical information for today. I hope that our listeners would understand it all. But right now, I would like to ask some other questions which won't be so technical. Maybe we'll try to explain what is the best use for your panels. What type of businesses, what niches used to take LONGi panels for their stations instead of some other.
So we have several sizes for best peak. Keep in mind that a Hymo X6 is mostly dedicated for the residential and C&I sector. For utility big projects, we have another series of the PV models.
It's not for a very big business. It's for something middle, yeah?
This Hymo X6 is mainly for the rooftops, residential rooftops, and business rooftops. For the very large scale PV farms, we have another series. We have another also entity that is handling those huge PV farms.
It depends on the size, or what is the reason why are you having this?
So we are having these different sizes due to the fact that with our experience, we know that in the residential scenarios, it's quite crucial to use small size PV modules. Why is that? Because we can put more smaller modules on the roof. They will fit better than the big ones. In most cases, of course.
Easier to install. Maybe we can use more space of the roof in this case.
Yes.
Yeah?
We have also some medium size modules. They have 66 cells. This module can be either used on the rooftops, on the residential rooftops, but also on the C&I rooftops. This module is very flexible because the largest modules cannot be installed horizontally. If you will see in the manual from the manufacturers, they will be stating that very big modules can only be installed with the clamps on the longer side of the PV module. And in our case, the 66, so the medium one, is very flexible model. It combines the good scale from the residential market. Of course, they are a little bit bigger. They are a little bit smaller from these bigger panels, the biggest panels, but you can mount it as well on the long side and on the short side with very high power output, more than 550 watt peaks.
And we even could combine it, yeah?
Yeah.
We need to put, if we don't have some place, we can put not horizontally, but vertically. Okay.
Totally. And also we have these 72 cells, which is mainly for the very huge installation on the roof, or even for the usage on the smaller farms on the ground.
I remembered one more myth that I've heard from the users, that this type of models, HPDC, is not very cool working in low light conditions. Is it true? Talking about the regions where is not so much sun.
So going through this myth, in fact, it's totally opposite. Due to the fact that we do not have the grid lines, any bus bars on the front of the PV module, it allows rays to enter the cell. It doesn't matter if the rays are shining directly on the cell or with the lower angle. So imagine the standard cell with the bus bars. If we will think about the sun rays in the low angle, those bus bars will generate shadow on the cell. And as far as we know, if we have a shadow on our PV module or on the PV cell, the module will just switch off. And in our case, due to the fact that we don't have these grid lines or bus bars, let's call it as you want, even if the rays are shining in the low angle, they can enter the cell because we don't have these grid lines in the front of the PV cell. That's why in our testing sites, in the extreme hours like 6 a.m. or 6 p.m., our models generated more than 20% more energy than TopCon within this hour.
Rafal, thank you very much for your time and detailed answers to my questions. I hope our audience has received quite comprehensive information about the hybrid passivated back contact technology. So now none of the myths will prevent them from making the right choice. At the same time, I would like to inform our audience that this September, Unisolar company will organize joint live seminar with LONGi and Sangro, one more our partner and pretty large inverter manufacturer. On this live meeting, we will cover a range of questions about the installation of solar power panels and solar plants at all. And if you are from Moldova, you can join us, meet the experts of all three companies face to face, and ask them the question you are interested in. The registration link we will put below, so hurry up, guys, because the number of places is limited. On this wonderful note, I would like to thank Rafal once again and to thank you all for your time and your attention. If you have watched this video so far, you are clearly interested in receiving fresh and important information about the solar energy market, and together with our partners, we are collecting it for you. So subscribe to our channels. We will leave the links in the video description, and be sure to click on the bell and ask the questions that is interesting for you in the comments below the video, and also share it with your friends. Have a good day and choose the side of light.